Okay, let's unpack this. Um, Maybe think about it like this.
Mm.
Your digital life as a developer, right? Early on, maybe you were really deep in, say, iOS development. You mastered Swift, Objective-C, built great apps, but all in that one single ecosystem.
Right, focused.
Exactly. But then, the landscape changes. Suddenly you need to build for Android too, using Kotlin, Java, maybe even web apps with React or something. You end up juggling different IDEs, different SDKs, different ways to deploy things.
Yeah, it gets complicated fast.
And what you'd really, really crave at that point is some kind of unified toolkit, something that lets you manage and interact with all those different platforms, like efficiently.
Makes perfect sense.
Well, in the rapidly expanding world of blockchains, a multi-chain wallet is kind of aiming to be exactly that for your crypto assets. It's like that unified interface, but for a multi-blockchain reality.
Yeah, that's a really compelling analogy, and it does highlight that developer need.
Yeah.
You know, for better tooling as things get more complex. What's kind of fascinating is how this specialization, this diversity of blockchains, it really mirrors how other tech landscapes evolved,
Yeah.
and it creates this genuine need for these consolidated ways to manage everything.
Exactly. And that right there is the focus for us today. We're doing a deep dive into the technical side of multi-chain wallets, and we're specifically thinking about you, our listener. Maybe you're a developer, you get blockchain fundamentals, the Ethereum ecosystem pretty well. Our mission here isn't really to go over the absolute basics again. Instead, we want to build up a solid mental model, a technical one, of how these things actually work under the hood.
Yeah, digging a bit deeper.
We'll, try to break down the technical bits step by step, figure out where they fit in the whole Web3 picture, and really understand the advantages and the trade-offs
Yeah.
from a technical angle.
And we've looked at quite a range of sources for this, everything from like beginner guides explaining the why, why we even need these things, to much more technical discussions about actually building them, the development side, and the security aspects too.
Okay, so let's kick off with the core idea. What is a multi-chain wallet, fundamentally?
So at its heart, it's a digital wallet, right?
Yeah.
Often it's just a single app, but it's designed specifically to hold and manage cryptocurrencies that live on, well, various different blockchains.
Right, not just one.
Not just one. Think Ethereum, Tron, BNB Chain, Solana, loads of others potentially, all inside one application interface.
Which is, yeah, a big contrast to those single-chain wallets like the original Bitcoin Core client, which is built just for Bitcoin.
Exactly. And if we tie that back to your developer analogy, it's like going from having, say, a totally separate IDE for Python, another one for Java, another for C++A, to maybe something like VS Code that handles multiple languages and platforms.
Yeah, a much more integrated setup.
The core problem these multi-chain wallets are solving is basically the friction, the complexity, and frankly, the inconvenience of managing all these separate wallets
Yeah.
as Web3 keeps expanding. I mean, we've seen Ethereum, then Unity Smart Chain took off, Solana, Polygon. Users who want to play in all these sandboxes were stuck, juggling separate wallets, separate keys, often totally different UIs for each one. It was getting cumbersome.
Totally. And it's not just about holding coins passively either, is it? The demand for actual interoperability for doing things across chains is just shooting up. Like you might have your cool NFTs on Ethereum, but you're also staking some tokens over on Avalanche for yield and maybe doing some fast trading on a Solana DEX.
Right.
Switching between completely different wallets for all that is just clunky. And for developers building apps that span these chains, they also need a smoother way for their users to connect and interact.
Yeah, absolutely. Which brings us to the fundamental question.
Mhm.
How do they actually do this? How do they give you this unified access? And it's really crucial to remember, I think, that underneath it all crypto wallets, including these multi-chain ones, they still rely on that absolute bedrock public and private key cryptography.
Right. The fundamentals don't change. Your public key is still like your address, the thing you share to get paid.
Exactly, your receiving address.
Yeah.
And your private key is the super secret password, the key that actually lets you sign off on sending funds out of that address.
Okay, so the multi-chain wallet isn't inventing some new kind of security model there. It's still using those key pairs.
Correct.
But the clever part is how it manages to give you distinct, valid wallet addresses across all these different independent blockchains, all from that one app.
That's the core innovation. Yeah,
Mhm.
it's not just like holding different tokens within one chain's wallet. It's actively interfacing with totally separate blockchain infrastructures. And a key technical piece here often is that many multi-chain wallets work by essentially controlling one main private key, or maybe more accurately, a set of keys that are all derived deterministically from a single starting point, that master seed phrase you get when you set up the wallet.
Ah, the seed phrase.
Yeah.
Yeah.
And that master seed acts like the root. From that root, the wallet can mathematically generate the specific individual private keys you need for different blockchains.
Okay, now this is where it gets really interesting, especially for, someone with a developer mindset. How does that one phrase manage keys across so many different incompatible chains?
This is where hierarchical deterministic wallets, HD wallets, come to play. It's a standard, and it's like the technical backbone for a lot of these modern multi-chain wallets.
HD wallets, got it.
Yeah. And the elegance of the HD standard is pretty cool, actually. You get that single recovery phrase, usually 12, maybe 24 words. That phrase acts as the master seed. And from that seed, you can deterministically generate a practically infinite number of private keys for different accounts. And crucially, this isn't limited to just one blockchain. The same seed phrase can be used to derive addresses and the private keys for them on lots of different blockchains, as long as they follow these HD wallet standards. There was a discussion on Reddit, actually, that touched on this. Someone was asking about MetaMask and how their one recovery phrase generates different private keys for all their sub-accounts within Ethereum.
Right. I have multiple accounts in my MetaMask.
Exactly. And that same mathematical principle, that deterministic generation, extends to creating compatible addresses on other chains, too, like, say, BNB Chain or Polygon, if the wallet supports it.
Okay, let me see if I'm tracking this right. So when I set up a multi-chain wallet and I write down that recovery phrase, that single phrase isn't just tied to like one specific address on Ethereum.
Right.
Instead, it's like a master key. It holds the instructions to mathematically generate a whole sort of tree of private keys. And different branches of that tree could lead to a unique address on a totally different blockchain network.
You've got it. Precisely. Think of the seed phrase as the root of the tree, like you said. And the different blockchains, or even different accounts on the same chain, are like the branches. The derivation path is just the specific set of mathematical steps, the path you follow from the root to get to a particular branch, which corresponds to a specific address and its private key on a particular blockchain.
Ah, derivation path. Okay.
Yeah. And as that Reddit user found out, this is exactly why a wallet like Trust Wallet or Exodus can handle multiple blockchains using just that one seed phrase. Your phrase contains the cryptographic blueprint, essentially, to rebuild all your accounts across those different compatible networks.
Okay, that also clears up something else from that Reddit thread then. Someone was confused because they imported their MetaMask recovery phrase into a different wallet app, and it only showed their main Ethereum account at first.
Yes, that's a super common point of confusion. It happens because different wallet apps might implement the HD standard slightly differently, or they might default to looking only at the standard derivation path for the first account on a specific chain, like Ethereum in MetaMask's case.
Ah, okay.
But as people point out in the replies on Reddit, even though all the accounts in your original wallet are derived from that same seed, they use different derivation paths to get there. So when you import the seed into a new wallet, it might just show account number 1 by default. But most multi-chain wallets will let you manually add or derive the other accounts. You might have to tell it to look at the derivation paths for, say, BNB Chain, or for account number 2 on Ethereum. They're all still mathematically linked to that original seed phrase.
Got it. Got it. That makes a lot more sense now, the whole seed phrase and derivation path thing. Okay, so we've talked about how you access multiple chains, potentially with one seed, but what about the wallets themselves, the types? Because there's a big difference in who actually holds the keys, right?
Absolutely crucial distinction, yeah. Especially for a developer thinking about security implications. When we talk multi-chain wallets, you need to understand the difference between self-custody and custodial. With self-custody, which is also called non-custodial, think Cruft, Trust Wallet, MetaMask, hardware wallets like Trezor or Ledger, Exodus, Ambire, Zango, Electrum, Blue Wallet, you, the user, have direct exclusive control over your private keys.
You hold the keys, you're responsible.
Exactly. The responsibility for security, for backups, it's entirely on you. The keys are usually stored locally on your phone or computer, encrypted, or on the hardware device itself.
So the analogy might be like managing your own physical server versus using AWS or Google Cloud. Full control, full flexibility of self-custody, but also the full weight of keeping it secure and running.
That's a good way to put it, yeah. Then on the other side, you have custodial wallets. This is where a third party, often a big crypto exchange like Coinbase, for example, manages the private keys for you. They handle the security, the backups. But fundamentally, you're trusting them with the actual custody of your assets. You interact via their platform, but they control the keys behind the scenes.
Okay. And it seems like from what I've seen, the vast majority of these multi-chain wallets we're talking about really lean towards that self-custody model, empowering the user.
That's definitely the trend, yes. The whole sort of ethos of Web3, decentralization, user control, it strongly favors self-custody.
Yeah.
And most multi-chain wallets are built around that principle, giving you the keys.
All right, so I've got a clear picture now of the basic architecture, the key management with HD wallets and seed phrases, and this self-custody versus custodial split. Let's dig into some of the key features and advantages that come out of this multi-chain approach, especially thinking, again, from a technical or developer viewpoint.
Okay. Well, one of the most immediate wins is just multi-chain blockchain accessibility. If you're building a dApp or a protocol, you don't want your users to have to download and set up 5 different wallets just to interact with everything you offer across different chains.
Right, it's a huge friction point.
Huge. So a single multi-chain wallet can potentially give users access to a whole bunch of blockchains, Ethereum, BNB Smart Chain, Polkadot, Avalanche, whatever, all from that one app. It dramatically simplifies the onboarding for users.
Yeah, that ease of access for users must be a massive benefit for developer adoption, too. Makes sense. What other technical advantages do we see?
Another really significant one, and this is where things get technically interesting, is cross-chain transferability. Now, not all multi-chain wallets do this natively, and it often relies on external systems, but many are integrating features to help you move tokens between wallets on totally different blockchains.
Bridging.
Yes, exactly. Bridging. As one of the sources, CoinCrowd mentioned, this often involves using cross-chain bridges or other kinds of interoperability protocols. Technically, how these bridges work can vary a lot. Some lock up assets on chain A and then mint an equivalent wrapped token on chain B. Others use more complex systems like liquidity pools.
Okay.
The point is, integrating access to these bridges directly within the multi-chain wallet aims to make that process feel much more seamless for the user who just wants to move their assets from, say, Ethereum to Polygon.
Gotcha. So the wallet is trying to abstract away some of that gnarly complexity involved in the actual cross-chain hop. That makes sense for usability. What about security? Does dealing with more chains automatically mean more risk?
Security is, yeah, it's absolutely top of mind, or it should be. While multi-chain wallets offer great flexibility, expanding that functionality can broaden the attack surface. The fact that most are self-custody means private key management is on the user, which gives control, but also responsibility. Beyond that foundation, though, good multi-chain wallets add extra layers. Things like multi-signature support, where you need multiple private keys to approve a transaction. That's really useful for shared funds or just higher security setups.
Like a company treasury or something.
Exactly. You'll also often see two-factor authentication, 2FA, maybe biometric logins like fingerprint or Face ID, adding layers to just accessing the wallet itself. And some are getting smarter, incorporating security checks that try to analyze the transaction before you sign it, looking for known scam addresses or potentially malicious smart contracts.
So it sounds like a balancing act, providing the access but layering on security features to try and mitigate the added complexity.
That's the goal, yeah. Balancing accessibility with robust security. Another angle is cost. Can these wallets help users deal with fluctuating network fees?
Yeah. Gas fees.
Exactly. Scalability and fee optimization is another potential advantage. Since the wallet connects to multiple networks, you, the user, get some choice. If Ethereum gas fees are sky high, you might look for an alternative. Maybe you can do the same swap or transaction on a cheaper chain like BNB Chain or Polygon, assuming the dApp you want to use is there too and your wallet supports it.
Right, you can route around the congestion, potentially?
Potentially, yes. And as CoinCrowd also noted, integrating support for Layer 2 scaling solutions directly in the wallet is another big step. Using something like Optimism or Arbitrum through your multi-chain wallet can drastically cut fees and speed things up for supported networks.
So for a developer, this means their users aren't necessarily priced out just because one network is expensive at that moment. They have options.
Precisely. The user gets to pick the most efficient path, hopefully, based on speed and cost, right there in the wallet interface. That's a big UX win.
Definitely.
And just one more technical point here from a development perspective. It's important to realize these wallets are heavily API-centric. They need to talk to the full nodes of all these different blockchains to get data balances, transaction history, and also to broadcast new transactions you want to make. They do this using the specific APIs, often RPC endpoints, that each blockchain provides.
Right, they're constantly pulling data from and pushing data to multiple different networks.
Exactly. Oodles blockchain highlighted this API-driven approach in the use of libraries like Web3.js or Ethers.js, but adapted for multiple chains. This abstraction is what allows the wallet to give you that unified view, even though the tech underneath each chain is quite different.
So yeah, quite a bit of complex engineering on the back end to make that smooth front-end experience happen.
A huge amount. But, while these advantages are compelling, we absolutely have to talk about the other side too. The trade-offs, the challenges that come with this multi-chain approach for both developers and users.
Okay, yeah, let's flip the coin. What are the big challenges or potential downsides we need to be aware of?
Well, number one probably is security risks, as we touched on and as CoinCrowd mentioned, plus discussions around things like that big multi-chain bridge exploit really hammered home. Complexity can increase risk. When you're interacting with more protocols, and especially when you bring cross-chain bridges into the mix, the overall attack surface just gets bigger.
Makes sense. More potential points of failure.
Exactly. A bug in one chain's implementation in the wallet, a vulnerability in a bridge contract they integrate with, even a flaw in the wallet's own logic for handling multiple chains. It could potentially have knock-on effects.
So really rigorous auditing, constant vigilance, it's non-negotiable for these systems.
Yeah, the interconnectedness is both a strength and a potential weakness. Absolutely. Then there's the sheer technical challenge of compatibility and interoperability. Hilo Labs made a great point here. Every blockchain is kind of its own little world. Different protocols, different ways of reaching consensus, different rules for validating transactions. Building one single wallet app that can correctly, reliably, and seamlessly talk to all these diverse systems. That requires a really flexible, really adaptable technical architecture. Developers have to handle all the specific quirks, different transaction formats, different ways gas fees work, how smart contracts are called on each chain.
So it's not just supporting the address format. The wallet needs to deeply understand the rules of the road for every single blockchain it claims to support.
Precisely. Which leads directly to the next challenge.
Yeah.
Constant updates and maintenance. The whole blockchain space moves incredibly fast, right?
Understatement of the year.
Yeah. New coins pop up. Existing chains upgrade sometimes with breaking changes and hard forks. Security holes are found and need patching now. Multi-chain wallet teams have to stay on top of all of that across all the networks they support. As Hilo Labs also pointed out, this means a huge ongoing development effort just to keep everything compatible, secure, and up to date.
Wow, yeah, I can imagine the dev teams feel like they're constantly chasing moving targets on multiple fronts. What about from the user's perspective? Are there unique hurdles for them with these wallets?
Definitely. User education is still a big one. CoinCrowd touched on this too. For someone new, or even someone used to just one chain, multi-chain operations can be pretty confusing. Concepts like bridging assets, understanding that your ETH is now wrapped ETH on Polygon, or why transaction fees are paid in Matic on Polygon, but ETH on Ethereum, or just keeping track of addresses across different networks. It can be a lot.
Yeah, it adds layers of complexity. It's like going from just using dollars to suddenly managing accounts in euros, yen, and Swiss francs, all with different transaction fees and exchange rates. There's a definite learning curve.
That's a good analogy. So designing really intuitive UIs, providing clear tutorials, good educational content, responsive support, it's all super important to help users navigate this without getting lost or making costly mistakes.
Makes sense.
And finally, just to reiterate for the self-custody wallets, which are most of them, that responsibility for private key management. It's a flip side of control. As the Trust Wallet article stressed, yes, you have full control, but the burden of keeping those keys safe, backing up that recovery phrase securely, it's entirely on you. If you lose it, your funds across all those connected chains are just gone permanently.
Yeah, it's that core Web3 trade-off again, isn't it? With great power comes great responsibility.
Couldn't have said it better myself. Okay, so maybe let's zoom out a bit now and think about the bigger picture. Where do these multi-chain wallets fit in the wider Web3 ecosystem?
Sounds good. What's their role in the grand scheme of things?
Well, I think they're becoming increasingly essential, really, for the overall growth and accessibility of Web3 by providing that single doorway, that one interface to interact with dApps, DeFi, NFTs across loads of different blockchains. They're seriously lowering the barrier to entry. Users don't have to feel locked into just one ecosystem anymore. They can explore more easily. Oodles blockchain argued, pretty persuasively, I thought, that multi-chain solutions aren't just a nice-to-have anymore. They're becoming basically essential infrastructure as DeFi and other Web3 activities spread out far beyond just Ethereum.
So they're kind of like the universal remote for the multi-chain Web3 world, making it more manageable and approachable for everyone involved, users and developers.
That's a great way to put it, a universal remote. Yeah. And if we look ahead, what's next? We can probably expect a few key trends. Gila Labs outlined several possibilities. Definitely a continued push for enhanced user experience, making things even smoother, more intuitive, especially those tricky cross-chain moves. We'll almost certainly see even more advanced security measures baked in, trying to stay ahead of the threats that come with complexity.
Makes sense.
Streamlined interoperability is another big one. Maybe more native integrations, less reliance on potentially risky external bridges, or just making the bridging process feel invisible. We'll probably see deeper DeFi integrations too, letting you stake, swap, lend, borrow, whatever, directly within the wallet interface across multiple chains.
So the wallet becomes even more of a central hub for financial activity.
Potentially, yeah. And then there's the ever-present challenge of regulatory compliance. As rules evolve globally, wallets operating across jurisdictions and interacting with different types of assets will need to figure out how to navigate that complex landscape.
Yeah, that's a whole other can of worms. It definitely sounds like these wallets are set to be even more fundamental to how we use the decentralized web going forward. And we saw quite a list of examples mentioned in the sources, didn't we? Trust Wallet, MetaMask, Exodus, Rabi Wallet, which is gaining popularity, hardware like Ledger Nano X, Coinbase Wallet's self-custody version, Ambire, Zengo, even Electrum for Bitcoin has some multi-sig, Blue Wallet, Crowd Wallet. It's definitely a busy space.
It is. And that diversity, that competition, it really reflects the demand and the pace of innovation here. It's a critical piece of the Web3 puzzle.
Okay, so let's try and wrap this up. If we were to boil it down, what are the absolute key technical takeaways a developer should walk away with about multi-chain wallets?
Okay, key takeaways. Technically, they let you manage assets and interact across different blockchains using unified key management. Often that's built on HD wallet standards, using a single recovery phrase as the master seed. But remember, even with that unified interface, they still rely on the fundamental public-private key security of each individual blockchain they connect to. They use APIs to talk to all these different networks, pulling data and sending transactions, and they might integrate bridging tech, which adds power but also complexity and a potential risk to handle moving assets between chains.
Got it. So for developers building dApps or protocols, understanding these mechanics helps create better user experiences. And these wallets open up the possibility of reaching users across multiple chains, giving those users more flexibility on where and how they interact, potentially saving them on fees.
Exactly. That's the upside. But always keep in mind the challenges, the security complexities of these interconnected systems, and the constant work needed to maintain compatibility and true interoperability. It's an ongoing effort.
Right. Okay, so here's a final thought then, something for you, our listener, to chew on, especially with your developer hat firmly on.
Mhm.
As this whole blockchain world keeps expanding, new layer ones popping up, layer twos evolving, interoperability solutions getting ever more sophisticated, how does the actual underlying tech, the architecture of these multi-chain wallets need to adapt? How do they keep providing that seamless, secure experience for users? Yeah.
Think about that balance, that tension between the convenience we all want, hiding the complexity, and the raw, messy reality of managing secure interactions across so many diverse, decentralized, and constantly changing networks.
That's the big question, isn't it? How to manage that tension effectively.
Yeah.
It's going to shape a lot of Web3 development in the coming years. Definitely something worth thinking about and keeping an eye on.
Absolutely. We encourage you to keep digging into the specifics if this sparked your interest. There's always more to learn.
For sure.
Thanks for joining us for this deep dive.